Welcome again to MSP Confidential. I have a wonderful guest today in Frank Branch, our data and AI engineering manager at ScalePad. Frank, it's so good to have you here to maybe nerd out a little bit on this AI stuff. Welcome to MSP Confidential. Now, for everybody, we have previously recorded this session, even though we're streaming this live on Friday. It is actually Monday, June 24th, that we're recording this because Frank and both myself and Frank were actually going to be away later this week, and so it was easier to get together to have this conversation. Now, we just had our ScalePad Innovate virtual event last Thursday on June 20th. And part of the event was filled with lots of interesting details on what ScalePad is doing with AI and some of the stuff behind the scenes on natural language processing, LLMs, and so on. And so we're going to try and get into a little bit of detail on that. Just from a core and academic perspective, because I think all those topics are super interesting for the sake of what we're doing in future platform capabilities and so on. But that kind of brings me to a simple question, like how does one end up in the AI field? Frank, and I suppose nowadays with so much talk about AI, this is a pretty common question, but this has been around for years. And so perhaps you've been around this for quite a long time.
I've been around for a bunch of time. I specialize in data and data curation, and I have a master's degree from the University of Washington in data curation. And data curation has gravitated heavily to AI as a field. So professional data curators, we have to learn AI, we have to understand AI, because in order to curate, huge quantities of data, you're not doing that by hand. Like, you can't do it by hand, you can't sort through it by hand. There's just the volume of it and the complexity tends to be too high. And so you have to leverage these AI systems. And so throughout my career, I just sort of learned how to do that, right? I did a little bit of that at AI, at EA. I've done more of that at my last job, which was a crypto company. And so various companies over my career. I started in just data analytics, and data analytics, of course, and data curation nowadays is an AI-centric field.
Sure. And have you found there's perhaps some inherent similarities or differences between the types of data at scale that one would manage at an EA or a crypto company, or now ScalePad, and devices and assets? I suppose from a principles perspective, a lot of things are similar.
From a principles perspective, theoretically, they're all the same. I mean, there's a theoretical foundation that you learn of how to do data curation, how to do information science in general. I would say that MSP data is probably some of the most complex data that I've worked with. It's way more complex than you'd find in a finance company or an insurance company, or not necessarily in an EA. In an EA, there's a lot of very complex data at an EA, because you're talking about all the information inside a game, which can be very, very complex. But in terms of complexity, I would say it's probably very high on the list. It's certainly higher than most e-commerce applications, for example.
Yeah.
I'd say in my career, this MSP data, game data, and I've also worked at McGraw-Hill Education. Education and student learning data are probably the most complex of the data that I've had. And it's when data becomes very complex, it's where AI starts to help you. More simple data with higher volumes, big data can be characterized as high volume data, which is most e-commerce data, but it's not that complicated. I bought a can of soda. That's not a complicated concept. The processing is a little different. When you have large amounts of complexity, that's where AI and other things really come into play. And in an MSP, you're talking about, anything, all the data that we have, tickets, what is a laptop, what is Microsoft Office, right? All that meaning has to be understood in order for the AI to function. And AI isn't magic. It doesn't understand that out of the box, right? It has to be trained and taught to understand what these things mean.
Sure. And I suppose even, and I hear a lot of talk about hallucination and AI making stuff up when it can't fill in the blanks with actual data. But I suppose in the process specifically of analyzing data sets, there's maybe less room for inaccuracies or hallucination. It's just performing a task at scale very quickly, given the capabilities. But maybe talk a little bit about hallucination. I know that's an interesting topic overall.
Um, yeah, there you can have hallucination, but it is more restricted, and you have to be a little more cautious about the way to look at it. Um, Examples would be if you think about trying to capture the sentiment of a ticket, like is the ticket positive or negative? You have a fundamental issue with a ticket in that the whole ticketing experience in and of itself is not positive, right? I'm complaining that my laptop is broken. So what you'll find an AI do is not so much hallucinate as be overwhelmingly negative, because the experience in and of itself is overwhelmingly negative. No one is writing, going into your ticketing system and saying, "Good job, my laptop's working today." Right? People don't do that, right? So it's a form of hallucination, right? Where it's more. I worry more about bias than I do about hallucination in the type of work that we do with MSPs, because MSPs, in and of their nature, are troubleshooters, right? And
Mm.
troubleshooter starts with the word trouble, so you automatically have a bias built into it. And you don't want that bias to affect the way in which it scores and rates things.
I suppose there are situations in which the passive aggressive client might actually send you a ticket that says, "Great, my laptop is broken," and so would an AI confuse those particularly sentiments in the
Oh,
situation like that?
absolutely.
Yeah.
An AI would absolutely confuse those things. It would absolutely have a problem with that. I mean, the the large language models feel like magic because they're very good at identifying linguistic patterns, right? They're very good at providing language feedback. I use one tied into my coding environment because code is a language and it's very good at predicting language patterns, right? And it speeds up the ability for me to write certain types of code. But it is limited to an understanding of language patterns on the data set it was trained on.
Mm.
And most of these large language models are trained on the internet. So every bias and every language thing you find on the internet is in these things, which is why sometimes you ask them basic arithmetic and they give you the wrong answer. Well, they give you the wrong
Interesting.
answer because someone said the wrong answer somewhere, right? And so it's not learning or doing the math. It's just repeating language patterns it's seen and heard before.
Yeah.
Right? And so if you go on the internet and you found an over preponderance of email that says the Earth, or sites that say the Earth is flat, right? Your your uh, your AI will hallucinate that the Earth is flat. Now, it does look at the amount of that, and the Earth is flat is not as loud on the internet as the Earth is flat. So you don't see those kinds of hallucinations. But when you do see hallucinations or biases, you find those because the training set, which in the case of almost all these like OpenAI is the whole internet, is trained on every bias and fundamental language issue that exists on the internet, right?
Mm.
So when you're crafting the tech, you have to craft it in such a way where you carefully craft the question to avoid the bias.
Interesting. And I guess suppose there's also the context of the maybe limiting the LLM's source of new information, new data. Ticket sentiment is a good example because you perhaps train it on specifically all the history of tickets the MSP had before, where you make some assumptions about how accurate or how biased or non-biased the conversation there is. And so, well, we could get into that, but maybe what we'll do is we'll jump into a couple of the topics, core topics that Chris was sharing at Innovate last week. And maybe we can talk about some of these things and get into some of the rabbit holes from there. So I'll bring up this a couple slides, and there's a number of terminology here that I had previously not really come across in my simple access to this kind of stuff, like RAG or RAG or AGI specifically. So maybe just from our perspective, how are we thinking about some of these terminologies, and what are we doing with some of these concepts internally as far as data and AI is concerned?
So yeah, each of these is sort of a technique, right? That you use for this. AGI doesn't really exist. AGI right now is artificial general intelligence, and it is the holy grail of AI. That is a thinking machine that thinks like a human. And contrary to the hype, we're years away from really having something like that that's effective. I can't say decades, but it's not tomorrow that AGI will be a thing. What's more is to try to get to something like machine learning versus an LLM, for example. Machine learning is when you train a machine directly, specifically to solve a problem. And you can do that because the problem is defined and you have a data set that defines the problem and gives examples of the solution. The ticket sentiment thing, for example, is not a bad thing to use for machine learning because you have thousands of tickets. A human can look at those tickets and say, this ticket had a positive outcome, this ticket had a negative outcome, and then you could teach the computer to look at patterns in those tickets and say, this means good, this means bad, and you get machine learning, right? An LLM is what we were just talking about, where it's trained on a very large language model, and it's designed to mimic human conversation, right? And it has this feeling of being smart because it's trained on more human conversations than any one human has ever heard, right?
Right.
So it knows conversations that NASA has had on its website that you've never even read, right? And so that's why it feels so much smarter than machine learning, but machine learning tends to be more accurate and less biased, especially if you're very careful in the way you perform the test. RAG is just another one of those techniques that you use to refine an LLM, right? So you can refine an LLM, you can teach it some of your specific vocabulary because different industries, different things have their own vocabulary, and maybe an LLM has a more generalized vocabulary and it can't talk to the specifics of that. You could use RAG, for example, to teach it the technology of Star Trek, right? And it would then know what a warp engine is and what that really means in Star Trek terms, right? So each of these is really a technique. Natural language processing is just, an acronym for any time you can type in a sentence and have it run a query. I'm very, very keen on natural language processing because that's where it takes your query and it converts it to a real machine query that can be run against a real organized and structured database. And a lot of what we're doing is building these structured databases, structured warehouses without bias very strictly, and then using natural language to make querying that data easier by just teaching the machine learning system the language of the data. That makes sense.
Yeah, I remember when Facebook would let you switch the language to pirate English at one point, and it would just return everything that you saw on the screen in pirate terminology. And I remember turning on for like 5 seconds, and I thought it was hilarious for 2 minutes, and then it got pretty old pretty quickly. But this reference of how people respond to certain things is interesting because I think in the context of MSPs, and maybe this is already happening, but some of the ticketing systems that have some kind of AI plugin or thing that it's helping people rewrite, their responses to sound more empathetic or do basic language skill things in their responses, may even be reabsorbing the responses as its own training for context, I guess, suppose, in how to do default responses in the future. Tell me a bit about sort of this recycling of data or reconsuming its own output, I suppose, because that could go on indefinitely.
It can go on indefinitely. When you hear about hallucinations or quote unquote, OpenAI getting dumber, a lot of that is because the internet is now littered with AI responses, right?
Mm.
And so it's eating its own dog food, for example. It's the best way to describe it. It's eating its own output. So in general, its output is a weaker version of the original text. It's a reconstituted, summarized version of the text, right? So then it goes and finds the same basic summary in 12 other places, and that reinforces the fact that it thinks it's correct, right? So it'll feed back on itself over and over and over again, strengthening that resolve that it is what it says it is, because it's reading its own output, right?
Mm.
It's kind of like the same thing that happens in real life with human beings who write, okay, I'm a human being, and I write my college paper, and my college paper is a reconstituted version of like 20 sources that I used. Now I have this college paper, and now someone cites my college paper and then reconstitutes that, and then someone cites that college paper, right? And it's the same thing that you would expect to happen in LLMs, especially the more generalized open ones. When that's where RAG comes in, because what RAG does is allow us to take the words and language in our own specific text and make that the most important thing that it sees, right? So RAG allows us to do. And I'm going to do a little bit of a shameless plug here. We use Databricks, which is a big data processing and AI platform, as a vendor, and they're extremely good at helping us sort these things out and figuring out how to do these things, right? Like they're extremely good at that.
Mm.
It is hard to do correctly. You could easily get something. I mean, that's why, the internet, you see these articles about how the AIs are getting dumber. Well, they're getting dumber because they're reading their own output, right? And then
Mhm.
considering that to be true, right? So you have to be very careful with that kind of reinforced learning.
Yeah. Well, speaking of dumb AI, let's delve into the next slide so we can foster more knowledge on this topic. Those are pretty common AI words that
Sure.
show up in all the output nowadays. But we had this idea of data warehousing, and it's something that we've been talking about
Hmm.
for a while internally. And I think at a high level, people hear data warehouse, and it's easy to imagine it's just a bunch of data and tables and stuff like that. But for the purpose of what we're doing here, to consume this for RAG, for NLP, natural language processing, for creating like multi-dimensional bits of information sources. Tell me a little bit about this sort of data warehousing concept as far as MSP data is concerned, because obviously the types of sources, as you see there on the left, can be quite complex. And this is just scratching the surface, of
I,
course.
this to me, this is the most exciting piece of the ScalePad OS that we're working on as a company, because um, we have we have power and visibility that a single MSP doesn't, right? Um, we have access to hundreds of MSPs, right, as clients, right? We can normalize all that data. We can standardize the vocabulary and language, right? So that things become comparable, right? And that's where you get some real power. You get real power isn't just, that the system is helping me, but the system is helping me understand where other people are doing better than I am, and then allow me to do better because I know that, right? Just a simple thing like ticket categories goes through a curation process. I got tickets. We map those tickets to a standard set of categories. That standard set of categories can then be compared against the standard set of categories that exist in other MSPs, right? So at some point, it doesn't really matter that you have, you guys, one MSP has called it, Wi-Fi incident, and another one has called it network incident. We can just say, oh, well, we got a network incident. How well and how expensive are network incidents to manage, right? And so that's where the power of data warehousing is. And it's in the curation process that occurs inside a data warehouse, right? A data warehouse hoovers in large quantities of uncurated data, and it spits out structured, curated, dimensional data out the other side, where everything is understood, everything means something, right? And the meaning is captured in that process, right? Which then enables an AI, because there's a huge store of it's almost like a giant dictionary, right? There's a huge store of language and understanding that can then be used by the AI to do natural language processing, to do querying, right? Can you imagine trying to get an AI to give you information about ticket categories when every MSP can call something different? It wouldn't do
Yeah.
a very good job of that, right? But if I curate that data, work with through our new integration center stuff that we're doing, and allow people to map that information, now we have a curated data store of thousands of MSPs, right? Now the AI becomes very powerful, right?
And so the process of curating, is this largely algorithm driven? Is this where a lot of sort of the quote unquote magic is happening in terms of, figuring out the rule sets, and the parameters and the guardrails for the curation of this data? Or is this largely a manual process at this stage?
No, it's mostly algorithmic. We design models, and then my engineering staff, they build those models and they use those models, and then they force the data to that based on algorithms, right? It you know the there's transformations that occur, and they tend to be by integration source, right? So ConnectWise tickets are ConnectWise tickets, and they have a particular structure. And once we understand that structure, we can manipulate that into a standardized model, right, by algorithm, right? So there's a combination of human and the other, and that's where I was saying that my team uses a coding API specifically designed to help with these types of curations. Another shameless plug, we use a curation API called Data Pilot, right? And a framework called DBT to do this work, right? And with between those two tools that we have, it becomes much easier to do the algorithmic stuff. Back when I first started, it was entirely manual, and some human being was doing it by hand.
Hmm.
Now there are tools that help us do that, but it's not automatic. Like, there's still a human involved, right? There's a human involved who using a tool that allows us to be able to get those things together and to be able to do them at speed, rapidly, and repeatedly.
Now, you talked about obviously consuming and maybe abstracting some of the data across thousands of MSPs to train our own models internally. And I guess that begs the question about, where the parameters of security and, separation of data really sit. And so I thought maybe I could ask you, or you could talk a bit about how we think about security of each MSP's unique data, and where we draw the line around what is constituted, or thought of as secret, unique MSP data.
Yeah. Well, we're a very high, we're a SOC 2 compliant, ISO compliant company. We're very, very security conscious here. Everyone's MSP data is theoretically in isolation. I mean, they all stored in the same data warehouse, but we have very tight controls on different MSPs and how the data is segmented within the warehouse, so that MSPs can really only see their own data. When we use their data to train things, we use it in aggregate. We don't use it in specific, right? So the training data doesn't care, that a ticket is from Bob, right? It just cares there's tickets, and it doesn't care about Bob or Fred or any individual client or anything like that. As far as it's concerned, the client's just a number, right?
Right.
And so that allows us to do these training and model work, because we can do the training and model work in aggregate. And that's what a multi-dimensional cube does, is once it gets out to the cube land, it's all aggregated now. It's all in aggregate. There's no knowing which MSP contributed to which piece of the aggregate anymore, right? We're highly conscious of privacy. In fact, basically only an MSP can see its own data, and only the vetted data engineering staff, so these are people who work for my team who have extensive background checks, et cetera, are allowed to see that data in any open form. No one else in our company has access to that, right? It's a very select number. It's my team, and that's about it, right? A few my team and a few managers above my head, right? And that's who can see this data outside of an aggregate, outside of a customer service purpose or another purpose. We're extremely tight about that, and we audit. Our data is heavily audited, right? I know I review audit reports weekly as to what my team touched and what they didn't touch. So I know if they're playing around with stuff they're not supposed to play around with. Not to mention they're all extremely professional, right? Like
Of
we
course.
hire top quality data engineering people with that, and we do complete background checks. So these are very professional folks, but the number of people who have access to the whole data set is extremely tiny, right? And everyone else can see it in aggregate and nothing more than that.
That's awesome, and I think this is an interesting area, just generally speaking, how this continues to evolve. Because I think, from an ethical perspective, there's a lot of conversations happening in the AI realm, and you see like the EU already putting out legislation that is perhaps inhibiting some of the capabilities that companies have around collecting data. And they've had things like GDPR, which already would allow, an individual to say, "Hey, I don't want my name or anything in your data." This is sort of the whole premise of GDPR, the right to be forgotten. And some of those things, we're starting to see legislation in the U.S. around some of these same privacy requirements. And so, I guess my question is, are these core things that we're trying to keep in mind as to the ability to forget information at any given point? I find that a fascinating challenge for a lot of companies. A GDPR request is often very challenging because you have to be able to sift through all your data to find a specific incident of a person's name and be able to remove it from all records, for example.
Yeah, GDPR is very different. Well, we as a company have a high security conscious. We try to be as GDPR compliant as humanly possible. We're a Canadian company. We're a Canadian chartered company. Canada's privacy laws are equivalent of Europe's,
For the
generally
most part,
speaking,
yeah.
and we abide by Canada's privacy laws because we are a Canadian company and we have to abide by Canada's privacy laws. So, and Canada's privacy laws are as strict as anyone's, right? Generally speaking, much more strict than the U.S. in terms of response of managing privacy. So we manage to that standard in our company. Um, there are always edge cases that are difficult to get. You have to remember the right to be forgotten is the right to be forgotten, not the right to be deleted, right? And that's a very important distinction, right? Because, for example, you might want to be forgotten, but I can't delete your billing records and your name is attached to a Visa card that we charged because that's a financial audit. It's a financial record. I'm not allowed to delete that, right? Because another arm of the government would come and tell me you can't prove that this revenue came from legitimate sources and you're not money laundering, right? Or any other number of different things, right? So it is it isn't the right to be completely deleted, it is the right to be
Hmm.
forgotten. And it is the right to be forgotten in places where that is not essential to some other critical business operation like billing or like those types of things, right? If you have been, and this is true for even commercial websites, like you go on a commercial website and Facebook is a little different because you have a right to be absolutely forgotten on Facebook because Facebook doesn't collect anything about you that is business operational unless you gave them a credit card for some reason, right? But generally speaking, say Amazon and you go to them and have a right to be forgotten, they have a right to keep their billing records and their sales records, and they're required by law to do that.
Yeah.
So they're not going to forget. They're not going to forget, that you bought a tube of toothpaste, right? Because they're not allowed to forget that you bought a tube of toothpaste, right? It's the same. I
Yeah.
used to work for Amazon, so I'm aware of this, right? And so you, we have a very, very structured way, and we keep track of all the different types of data, and we catalog them, and they're heavily tagged, so we know where a date may where a name may appear that has to be redacted versus a name place where it can't be redacted. Does that make
Right.
sense? We track all that in model information that keeps track of all that information for us. I mean, half of what my folks do isn't just writing code. They're all professional curators as well. They curate that data, they describe it, they create metadata that lets us know what can be redacted, what can't be redacted, and we do all that as part of this warehousing process so that we know somebody comes to us and says, I would like my name to be removed. We can say, well, it can be removed from here and here, but not there, right?
Very, very interesting. And I think sometimes folks do not necessarily know about and understand is not difficult part of that process necessarily, but did not know about the requirements to keep some of the data associated in those ways. So that's interesting. Let's get back to the cube for a sec, because when I saw this slide, I thought it was really interesting. And as we got into a bit of the conversation about Cognition 360 specifically, for example, and some of the capabilities that we're exploring, we even did a demo on the natural language processing of asking a very deep question that you would maybe ask your finance manager, as part of a weekly meeting. Talk me through a bit of the cube and some of these different parts of it.
Um, so a cube is an interesting thing. You always show it as a three-dimensional thing, but they're actually n-dimensional. They can have more than three dimensions in them. And the interesting thing about them is they turn your data into sort of a mathematical geometric problem, right? Computers are very good at math, and they're very good at analyzing mathematical patterns. Does that make sense?
Yeah.
So when you output data and you structure it into something like a cube, what you've done is you've put a geometry onto that information. And it's a geometry that the computer can traverse at high speeds that a human can't, right? And so it allows for those sort of things. It requires data professionals who know how to generate these things and build them correctly, right? So that they are, readable. But it again isn't magic, it's math, right? It's just extremely complicated math. What the interesting thing is when you go into information science and as a career, the kinds of math you learn are non-parametric statistics, graph mathematics, and matrix mathematics, right? And you learn those kinds of math, which are weird sets of math that other people don't learn in their regular schooling, right?
Yeah. Literally
Because
the matrix.
because those types of mathematical patterns are inherent in information, right? And because computers are so good at math, right, they can traverse those mathematical patterns and find answers to questions that you may not even be able to see, because they can traverse the math faster than you can. Right? And so that's the power of a cube. Whenever you hear people say you can slice and dice your data, what you're really doing is you're taking a cube and you're cutting slices out of it based on the patterns, the math of those cubes. And then it's just returning that slice to you. So the slice and dice nature of it, and same thing with the drill downs. When you drill down from one report to another report, all you're really doing is you're going from one dimension, a higher dimension of the cube, to a lower dimension of the cube. Right? But it's all in this large mathematical structure that allows the computer to return those results fairly quickly.
Now, one of the things Chris talked about, and this is, I guess, one of the things that's so interesting about where the capabilities can bring us to in the future, is this idea of ScalePad agents that can actually perform actions on data behind the scenes. And I think one obviously aspect of all of this has been just getting information, but another very different one is performing actions and performing the correct action, based on some interpretation that is, I guess, LLM driven or some kind of ML driven bit of information. And so how are we thinking about, I guess, the guardrails around performing actions in data sets after we've learned something that we want to take an action on?
I think that, there's always the guardrail of the human having to be involved in the loop. We as a company we're if I'm going to build, if we're going to have an agent, you're going to turn that agent on. We're not just going to turn an agent on and all of a sudden it starts doing things for you, because that would be a weird user experience. In the end, everything that we do is about a user experience that we're trying to generate that's comfortable for users. Right? We start with the user experience and work our way backwards. We don't start with the cool tech and then work our way forwards, right? And so we don't want a weird user experience where all of a sudden you're getting 1,000 tickets because we turned on an agent, right? Instead, what we do is we build an agent, and then we would say, hey, there's new information for you. This agent discovered these things about your business. Oh, let's use an example. Oh, generally speaking, this customer's SLAs are longer than everyone else's, or SLA violations. They have more SLA violations than everyone else does. Something's going on with this customer, right? Do you want us to send an email, right? If you say yes, you said, do you want us to send an email in the future when these conditions occur? Yes. Now you've activated an agent. You've done that automation for you. We're not going to just suddenly start spamming emails to your clients, right? Because that's a weird user experience, right? And so we start with the user experience of like, what are we trying to accomplish? What is the right way for an MSP user experience? We use our expertise and the folks in our business and subject matter experts who've been working in the MSP industry for years to explain what that user experience and that interaction really ought to be. And then we look for insights based on that. And then the agents can be turned on to just do, instead of you having to look at it every day, it just does it for you. The better example would be, automating backup failures of some sort to do things like that with backup radar. Or the more interesting things is when we start being able, as a company at scale, be able to do things like, oh, you have 12 backup servers and the warranty on 3 of them is expired. Maybe you don't want your backup servers to have expired warranties, right? That's usually a critical system. You probably want to have your backup service still under 24/7 warranties, right?
Right.
And so we're looking for those kinds of patterns and insights based on our deep industry knowledge, and then we're converting them into agents that can act for you. But ultimately, in the end, the human is still making a decision. We don't take it out of the human's hands, right?
Right.
Because sometimes it could be an error. Maybe this month I have no money and I don't want to buy 4 new warranties, right?
Now, the natural language processing side of all this I find super fascinating because I guess as the cube and these geometrical shapes of data are conformed, maybe try to, as plainly as you can, for my sake, the NLP side of this, how is the data being traversed in the concept of a cube to like assemble this very complex request?
So if you look at what you have here, typically you have these questions and they have different components in them. Like, and this is a really good slide as to what that is. You have, that's a measurement, right? Average is a form of aggregation. It's a function. I want to average it. I want to sum it. I want a standard deviation. There's endless numbers of statistical, functions, right? Resolution time is the measurement of what we're trying to do. Based on a ticket, we can look at how long it took to do the resolution of that ticket, right? So it's a measurement. And so what we try to do is we build a cube is just a series of facts, right? So we store a series of facts, and that series of facts almost always has a time element to it. When did this fact occur? It almost always has some measurement of it, right? So a fact, for example, is the resolution time of this ticket was 23 minutes. That's a fact. That fact is stored in the cube, and it is referenced through multiple dimensions, right? It's referenced through the ticket category. It's referenced through the client. It's referenced through the technicians that are attached to it, right? It's referenced through any one of those things. So that fact can then be aggregated in a function based on any of those variables, right? So you could just say, what was my average ticket resolution last week? And it would know, okay, look at all the tickets last week, look at the resolution time and average that. It can go even smarter because it's a multi-dimensional cube and say, you know what? Tell me what all the average ticket different resolution times for network issues were last week. Since it knows one of its dimensions is network issue, is ticket category, right? It can just do that. And the cool thing about natural language is you can see here that, at least in English and in almost every language, by the way, there's a natural formation of questions. Right? They follow a natural pattern. So natural language is like anything else. This is pattern matching, right? And it knows how to convert this into an SQL query. And it does that because we taught it the schema and the curation of the SQL query. Because the cube is structured and defined, right? The natural language processor knows what a ticket is. It knows a ticket is this cube. It knows what a resolution time is because a resolution time is this column in this cube, right? It knows what a week is, and it knows by day because those are time elements that we taught it. Does that make sense?
Yeah. You know, the infiniteness of it is extremely compelling. I don't know who out there has been watching Dark Matter as an example, but you know, I guess there's an infinite number of dimensions, and every time there's a change in the time element, there's another set of infinite number of dimensions possible with every angle or slice or view of the data, and for some people, it's like thinking about the infinite nature of our galaxies, for example. Some folks get really overwhelmed by the thought. I find that I'm comfortable in that overwhelming feeling. Like it's just, yeah, it goes on forever. But I suppose this can be, particularly overwhelming with data when you can go find it in so many different directions. And I don't know what my question here is, but how do you deal with the infiniteness of data in this scenario?
I have a weird brain. I, I have yeah, I don't know. Either A, it's an occupational hazard, or B, it's an innate talent that makes me good at my job. I don't know which one it is, but I have the ability to see patterns, large, complex patterns in things, right?
Mm,
Um, and most of the folks on everyone on my team has that same skill, right? It's either an occupational hazard or it's an innate thing. I see patterns everywhere, so I kind of say it's kind of my screwed up brain. I see patterns everywhere, right? I look at large amounts of data and I see patterns in them. I watch TV and I can see
mm.
patterns in them. I see patterns everywhere because that's just kind of how my brain is wired, to do that, right?
This is an
And
interesting behavior
so,
that exists in MSPs as well, Frank, because for a large part of like dealing with a daily ticket that is submitted by an end user, as an example, there is so much interpretation, and sometimes like deriving a meaning that it was not said in the ticket words at all. Like, oh, it sounds like by what they're saying here, what they were actually trying to do was Y, but they were explaining X. But I know that what
mhm.
needs to happen is Z, and so it's an interesting thing. And I'm my thought around this is, you know, will the responses MSPs give to questions that were not asked in tickets something that the language models can learn as a plausible answer for an issue? And I don't know. I'm kind of grasping at straws here in my
There,
understanding.
possibly, yeah. I mean I mean, large language models are just my screwed up brain on steroids, right? They're just able to see huge patterns that even people who are really good at seeing patterns can't see, right? And so a lot of that natural language processing feels like magic, but it isn't really magic. It's just pattern matching, right? A question is an inquiry. A SQL query is an inquiry. Converting one pattern to another pattern isn't that hard, right? And so if you think about those things in those terms, right, then yeah, a large language model can do those sort of interpretations, right? And just like MSP technicians have been doing it for years and years and years, do it as muscle memory, right? The computer sort of does that. And most of the data professionals that work on my team or myself have done so much pattern analysis in our careers, looking at patterns that it's muscle memory for us. You just stare at it and go, okay, I see that pattern there, or I see this pattern there. Okay, obviously this is going on, right?
Right.
And so the data department of a company is its brain is the best way to think about it. And it does what brains do. It memorizes things and finds patterns and then acts on those patterns, right?
I like that, the data department. That's a perfect way to put a little touch of finalization on this conversation. Frank, very, very, very interesting. And I think obviously the industry as a whole continues evolving very rapidly. Malcolm Gladwell a couple weeks ago at the PAX 8 Beyond conference was suggesting that the majority of us don't even understand really what the capabilities of AI in a larger context really are. And I think, it's kind of like we never imagined we'd be not using a Betamax or a VHS, or that, there's all these very, very dimensional shifts in technology that are driving change that humans never thought would be possible. And I think that AI is going to be one of those big ones for sure. But what excites you, I
Yes,
guess,
AI
as
is definitely going to drive change.
yeah,
AI is definitely going to drive change. There's a lot of myth and mystery around AI. Sometimes I think that's intentional by AI companies as part of their marketing, right? Because it's good marketing, right? Like lack of a better, it's really good marketing, right?
yeah,
You know, I think Sam Altman's a very good marketer. As much as he might be a CEO and running a large AI company, he's also very good at marketing, right? He's very good at talking about, in marketing and selling himself and selling his business, right? I caution MSPs to be pragmatic about it. ScalePad is pragmatic about it. We're pragmatic about where AI helps, where AI doesn't help, where it's magic, where it's not, right? It feels like magic. It feels like it's, going to replace every artist. It's not, right? I think we have to be, there's a level of pragmatism we have to, but it is a revolutionizing technology. It will automate many things that people do now. And my theory is that what's exciting about it is it's going to free those people up to do other stuff that an AI can't, right?
sure,
And that's the more important thing. How many mundane things do people in MSPs do, and they can't get to the more proactive things that would optimize the business? And AI is probably not going to get to those proactive things very well, but it can automate a lot of that simplified stuff so that your humans are more able to do the more proactive stuff to optimize your business in a way that an AI can't. So that's the way I would think about an AI. This AI is going to be good at optimizing. An AI is not going to make a Picasso. It's going to make a good fake Picasso, but it's not going to create a whole new artistic movement. That's not an AI. But what an AI will do is lay out your newsletter, right, for you, or build you a generalized e-commerce website that all looks the same, because they all do, right? It'll do those kinds of things, which will enable humans to do more interesting things, like invent new artistic movements and
yeah.
things like that.
Yeah, very interesting. Well, Frank, it's been a pleasure. Thank you so much for letting me dig into some of these questions. I know my understanding is very superficial at this stage, but it's always great to sort of get a sense of how we're thinking about it purely from this conceptual standpoint. And I appreciate all your knowledge and the work you do at ScalePad with your data and engineering team. For everybody else, thank you for joining us. We're here every Friday at 12 noon Pacific, 3 p.m. Eastern for MSP Confidential. We hope to see you again next week. And until then, have a great rest of your day. And thanks again, Frank. Awesome to have you.
All right.